As the world shifts from fossil fuels to embrace nuclear power, there's a pressing need to demonstrate safe, more cost-effective and innovative solutions for handling radioactive waste. In the EU, most of the low-level radioactive waste is already safely disposed of. Nonetheless, many EU member states with small inventories still store their low-level waste. Meanwhile, less than 4% of intermediate-level waste is disposed of. Nuclear power plant operators, waste management organizations, research entities, and the nuclear supply chain came together in a 4-year research project with a budget of over 20 million euros to address this pressing global challenge. The project created new technologies that handle low-level and intermediate-level radioactive waste in a safer, more efficient, economical, and environmentally friendly way.
The PREDIS project was developed in close collaboration with end users. We wanted the project to have impacts in industry. So we focused on their priority waste streams, decontamination of metallic wastes, and the treatment of liquid and solid organic wastes. In order to make this happen, we looked at developing characterization techniques to better understand the waste, the development of novel treatment and processing technologies. We did testing to ensure that the products were suitable for the waste acceptance criteria, and also looked at modeling the performance of these in the long term.
Digitalization solutions have been used for concrete packages, especially to understand the cemented waste's evolution and durability. For instance, developing gamma and neutron sensors, acoustic emission, non-destructive testing to evaluate the durability and performance of packages that are in interim storage. Some of the biggest accomplishments of the project are especially related to new materials. For instance, the developments of geopolymers and magnesium phosphate cements as replacements to traditional binding materials for immobilization. It was important that we checked these new types of materials coming on the market and also verify their durability performance, that they're going to be safe and accepted by the regulators, and ensure that we can utilize them in practice. Another large accomplishment of the project was related to the digital twins and handling of big data and decision-making to reduce risks in understanding of interim storage of waste packages.
One significant achievement was the development of a strategic research agenda to guide European research in pre-disposal over the next 10 years. This was built up in really close collaboration with a whole range of stakeholders across different countries and different parts of the nuclear sector. We've made lifecycle assessment and lifecycle costing integral within the program. This allows us to test that our developments are both environmentally sustainable and also financially viable.
Many of the project's innovations were validated through real-scale demonstrations in the industrial end users' facilities, taking technologies from the lab to the factory floor, showing readiness for deployment.
The PREDIS project greatly appreciates the end users group who contributed in some cases financially, as well as contributing materials and data and the facilities where we could do demonstrations. And this helped ensure that our results are utilized by that group of over 25 industrial end users from around Europe.
The project, led by VTT, was funded by the European Commission's Euratom program and brought together 47 partners from 17 countries. The PREDIS project has been an important hub for training and knowledge dissemination with webinars, conferences, and mobility grants for competence development. During the project, over 120 organizations from 29 countries were involved as stakeholders participating in PREDIS public events. To learn more about the project and access hundreds of technical reports, case studies, conference proceedings, and webinars, please visit our website. Building on the success of PREDIS, the next EURAD2 European partnership will develop further and demonstrate sustainable solutions for radioactive waste management from generation through final disposal.